Alright guys, today we're going to be looking at functions and how functions work. So, a function is where a domain and a range have one member, and we typically look at them with graphs. But today we're going to look at them with mapping and graphs. So we're going to look at them two different ways. So first you need to understand what a relation means. A relation is just, is just a set of ordered pairs. So your x and your y. So relation is just a set of ordered pairs. So x, y. And it's when multiple of those come together. So when you have like 5 x's and y's. And in a relation, we don't call them x and y. We call them domain and range. And domain is the x coordinate. So whatever comes first. The range is the y coordinate, whatever comes second. And you can just remember that by alphabetical order. X, Y, D, R. So D comes before R. So domain is the x coordinate, range is the y coordinate. So a relation has to have a domain and a range. Domain being x, range being y. Alright, a function is when each member of the domain has exactly one member of the range. So each member, it's terrible, of the domain matches with one member of the range. And that's how you know if it's a function. If each member of the domain matches with one member of the range, then we'll say it's a function, meaning it works correctly. Alright, so let's make this all make sense. So, here is a relation. Just our x's and our y's, and the question is the relationship a function? Explain. So this is what we call a mapping diagram. Basically, we listed out the domains, we listed out the ranges, and then we put arrows. So 0 goes with 1, 1 goes with 2, 1 goes with 3, 2 goes with 4. Based on this. Because domains are always the first or the x, ranges are always the y's. So we say things are a function if each domain goes with exactly one range. And you can think about this like a vending machine. Like if I press 0, let's say 0 is Diet Coke on the vending machine, it should pop out a Diet Coke. Now, let's say 1 is Coke. 1 should only pop out Coke, but right now 1 is popping out a 2 and a 3. So in other words, 1 is popping out a Sprite and a Coke. That's not a function. Right here is showing us that this isn't a function because 1 is popping out 2 different numbers. That can't happen. 1 can only produce one number. So there are 2 range values. So if you notice, there's 2 range values for the domain value 1. So in other words, 1 popped out, a 2 and a 3. That makes this not a function. It can't do that. It can't pop out. 1 cannot produce a 2 and a 3. So this domain has 2 ranges. That can't happen. Alright, you're going to need your book out too. So you're going to get your book and go to page 401. And you're going to make a mapping diagram for example 1A and example 1B on the top of page 401. And when you're done with that, come back and check your, when you're done with that, come back and check your answers. Alright, so hopefully you're checking your answers here. For example 1, hopefully you said no, because 2 popped out 2 and a negative 2. That can't happen. The Diet Coke button can't give you a Coke and a Diet Coke. So that is not functioning. The other example does work because negative 5 gives negative 4, 0 gives negative 4, and 5 gives negative 4. Even though all our ranges are the same, that doesn't matter because each of our domain gave that range. So it doesn't matter. There could be 3 Diet Coke buttons, but they all produce a Diet Coke. So that's okay because each arrow only goes to one number. So that is, yes, it is a function. All right. We are going to do these examples in class, so don't worry about these. Let's flip to the back. All right, so now there's another way you can do this, and it's called the vertical line test. So now we're going to take the domain and range, put it onto a graph, and then work from there. So right now, all I'm going to do is place these domains and ranges on the graph. And remember, they're literally just coordinate pairs. So -4, -3. So I'm going to go to -4, down to -3, and I'm going to put a dot. Hopefully your dots are better than mine. Then I'm going to go 2, 0, 2, 0, 2, 3, 4, 3, 5, -4. So you should have 1, 2, 3, 5 dots. 1, 2, 3, 4. Perfect. Now, this is a different way to figure out if it's a function. So what it has to do, it has to pass a vertical line test. And all that means is, this might be hard for me to show you on here, but all this means is if you were to drag a vertical line across this, like this, it should only hit the vertical line once at each stop. So here, it only hits 1 dot. But here, if you notice, it hits 2 of the dots. That means that that is not a function because that number 2 domain is giving out 2 ranges, 0 and 3. So this means that this does not pass the vertical line test. So you can pass a pencil across the graph. So just like this is my pencil. Then you want to keep the pencil vertical. You want to keep the pencil vertical to represent a vertical line. So you just want to, you want to keep the pencil vertical to represent a vertical line. The pencil, if you notice, this pencil passes through both 2, 0 and 2, 3, which means this relationship is not a function because it hits twice on this, because it hits twice on this vertical line right here. So if this was my pencil, this black line, it hits twice, and that makes it not a function. So that's another way to figure out if something is a function. All right, I'm going to have you do numbers. Go in your book and complete example 3A and B, and I want you to do the same concept, and we will check those tomorrow in class. So you need to do example 3A and example 3B. And if it goes off the page, just like it says here, just estimate its placement. And we'll check those tomorrow in class. All right, guys. See you tomorrow.